Okay, so this example is to do with using coded data to find a standard deviation. So the example is as follows. We've got the weekly income I of 100 women workers recorded. The data is coded using y equals I subtract 90 over 100, and the following summations were obtained. So the sum of y is 131, and the sum of y squared is 176.84. We were asked to estimate the standard deviation of the actual women workers' weekly income. So the first thing we want to do is find the standard deviation of y, and then once we know that, we'll be able to decode it to find the standard deviation for I. So crucially, standard deviation for y, which I'm going to denote as sigma y, like that. From the formula for standard deviation, that is equal to the mean of the squares, so sum of y squared over n, subtract y bar squared, and y bar is just the sum of y over n. So we've got y bar, the mean, is the sum of y over n, and the sum of y was 131, n was the number of women, which was 100, so 1.31. And we can start substituting things into the standard deviation formula. So the standard deviation of y is going to be the square root of 176.84 over 100. So sum of y squared over n, subtract the 1.31 squared that we calculated a moment ago. So feeding that into a calculator, I'm getting that that is equal to 0.22869. And then we need to use the coding formula that we were given in the question to find what the standard deviation of the actual incomes are, i.e. the standard deviation of I. So the formula that we had, it's actually really up near the top. So it's that y equals I take 90 over 100. When you code data, the standard deviation is only affected by multiplying or dividing. If you add or subtract something, that doesn't vary, it doesn't affect how much the variation is. So we've got y equals I take 90 over 100. The minus 90 is not going to change the standard deviation. The divided by 100 will. So the standard deviation of y is the standard deviation of I over 100. So in other words, the standard deviation of I is 100 times the standard deviation of y, which is what we just calculated a minute ago. So it's 100 times the 0.22869. So that comes to about 22.9. And that's it, that's the answer to the question.